Welcome to homework.
So let's draw two free body diagrams for this. For the two objects, we have going straight up would be force normal. This would be m sub 1. So going straight down would be m sub 1 g. The second mass, m sub 2. Going straight up would be force normal. Going straight down would be m sub 2g. This would be the direction of the acceleration. So this would be plus y. And then going straight down, this would be the direction of the acceleration for the first mass. So this would be plus y. We're going to make the assumption that the direction of the acceleration would be in the direction of motion for both objects. So here, a sub c equals a sub e, and this would equal a. So we can say m sub e g minus force sub t. This would equal m sub e times a, and then force sub t minus m sub c g would equal m sub c a. Now here, this would be for the second mass, and this would be for the first. So this would be the essentially the Newton's second law applied to both masses. This would be our answer for part A. And then for part B, they want us to add the equations together in order to solve for the force tension, essentially. So we can say that, my apologies, this is force tension, my apologies. So we can say for part B, we can say m sub e g minus force sub t plus force sub t minus m sub c g. This would be equal to m sub e a plus m sub c a, where a is the acceleration of the system as a whole. Therefore, m sub e g minus m sub c g equals m sub e a plus m sub c a. Let's get a new workbook. We know that the acceleration would then be equal to the mass sub e minus the mass sub c divided by mass sub e plus mass sub c g. This is going to equal 1,150 kilograms minus 1,000 kilograms divided by 1,150 kilograms plus 1,000 kilograms. And this will be multiplied by 9.80 meters per second squared. And we have that the acceleration is then equal to 0.68 meters per second squared. So let's take note. This would be the first answer, and then we want to find force tension. So we know that force tension would then be equal to m sub c times g plus a. And we would then solve, and we can substitute m sub c multiplied by g plus m sub e minus m sub c divided by the sum of the masses times g. This would equal 2 times m sub c, m sub e, divided by m sub e plus m sub c. Again, keep the factor of g, and we can solve. So force tension would then be equal to 2 times 1,150 kilograms times 1,000 kilograms divided by the sum. So it would be 2,150 kilograms multiplied by 9.8 meters per second squared. And we have that the force tension is approximately 10,500 newtons. This would be our second answer for part B. That is the end of the solution. Thank you for watching.